We spend so much time obsessing over the really flashy parts of AV tech, 4K, OLED, all the stuff that looks great in a press release. But if you walk into, say, a high-end security center or a duplication facility, you realize the real work isn't on the screen. It's in the plumbing behind the rack.
That's a perfect way to put it. That plumbing you're talking about, that's really what separates a professional system from just a hobbyist project.
Exactly. And that brings us to the gear we're digging into today. The Kramer 105VB. It's a 1.5 composite video distribution amplifier.
Right.
Now, I have to ask, in a world of HDMI and IP video, talking about a composite DA feels a bit like reviewing a really, really nice typewriter. Is this actually still relevant?
It is, surprisingly so. And here's why. You've got these massive industries, CCTV, live staging, legacy duplication, that still run on analog composite signals.
Okay.
The problem is composite is, well, it's fragile. If you try to send it to a bunch of different places without the right support, the signal just falls apart.
Right, and that's the distribution amplifier part of the name. But let me play devil's advocate for a minute.
Go for it.
If I just need to send one camera feed to 5 monitors, why can't I just grab a cheap passive splitter? Why do I need a powered box like the 105VB?
You could use a passive splitter, but believe me, you would hate the result.
Why?
When you split a signal passively, you're literally dividing the voltage. You mess up the impedance. What you see is a darker picture, you get reflections, ghosting. It's a mess.
Oh.
The 105VB doesn't just split it. It buffers and isolates each output.
So it's active isolation.
Precisely. It takes that one input, rebuilds it, and then drives 5 completely separate, fully powered outputs.
Meaning monitor 5 gets the exact same signal strength as monitor 1.
The exact same. And there's zero interaction between them. If one monitor shorts out, the other 4 don't even flicker.
Okay, that explains the amplifier part. But looking at the spec sheet, there's a number here that just feels like total overkill.
Let me guess, the bandwidth.
Yeah, the bandwidth is listed at 400 megahertz. Now, correct me if I'm wrong, but standard composite video tops out around, 6, maybe 10 megahertz?
You're right in the ballpark, yeah.
So isn't 400 megahertz kind of like buying a Ferrari to drive in a school zone? Why would you possibly need that much headroom?
It does sound excessive, but in the world of analog signal processing, headroom is everything.
How so?
Think of it like a 10-lane highway that was built for a single bicycle. That bicycle doesn't need 10 lanes, but because they're there, it will never, ever hit traffic.
So it's about linearity.
Exactly. If an amplifier's bandwidth is too close to the signal's frequency, you start getting phase shifts and roll-off at the high end.
And in video terms, what does that look like?
It looks like smearing or color bleeding. By pushing the bandwidth all the way out to 400 megahertz, Kramer makes sure this device is completely transparent in the part of the spectrum that matters. Zero phase shift.
That makes perfect sense. It's not about speed, it's about perfectly maintaining the wave shape.
You got it.
Speaking of which, there's another spec here. Differential gain is listed at 0.1%. For anyone who doesn't live and breathe this stuff, what does that actually mean for the picture?
Oh, that's a huge one for color fidelity. Differential gain measures how much the color saturation gets affected by the brightness of the image.
Whoa.
On cheap gear, if a scene gets really bright, you might see the colors wash out or shift. A spec of 0.1% means this thing is rock solid. The color stays true no matter the luminance.
Which is probably why they built it with BNC connectors instead of, consumer RCA plugs. The VB in the name is for BNC, right?
Correct. There's a 105V model that uses RCA, but the VB is for the pros. BNC connectors lock.
And that matters.
It really matters. If you're in a rental or staging environment, say a live concert where subwoofers are shaking the floor, you cannot afford a cable jiggling loose. BNC gives you that mechanical stability.
Let's talk about that environment. The source mentions this fits the Kramer tools form factor. It seems small, but is there a strategic reason for that size?
It is all about density. The source notes that you can mount 3 of these units side by side in a single 1U rack stacker.
So it's modular.
Hugely so. An integrator might need a video DA, an audio delay, and maybe a transmitter, all in the same rack. With this, you can mix and match 3 different functions in just one slice of rack real estate. It keeps the plumbing clean.
And at around $184, it's definitely priced like professional infrastructure.
Yeah.
This is not a throwaway gadget.
No, you're paying for that install and forget reliability. It has a signal-to-noise ratio of 80 dB, which means it adds virtually no noise to your system. You put it in the rack and it just works for years.
And that's the real goal of good infrastructure, isn't it? To be invisible. But before we wrap, this whole thing brings up a really interesting contradiction.
We are.
We're rushing headlong into an all-digital IP-based future, yet companies are still making this kind of high-performance gear for a format that was standardized in the 1950s.
Yeah.
It really makes you wonder, why is legacy analog video so incredibly sticky in critical infrastructure like security or medical imaging, even when we have better technology?
It suggests that sometimes, raw simplicity and zero latency will always beat high resolution.
Something to ponder next time you see a grainy security camera feed. Thanks for listening to this deep dive into the plumbing of the video world. We'll catch you on the next one.